All right, ladies and gentlemen, welcome to today's lesson about line of best fit and correlation coefficient. So hopefully by this point you know how to make a scatter plot. You can put all those dots in there. You can kind of tell if it's got a strong correlation, a weak correlation, kind of a moderate correlation, or no correlation at all. And what we're going to do today is be getting something called the line of best fit. And what a line of best fit is, we saw this example yesterday, is if your data has a general pattern to it, and what's very useful is being able to take that data and then approximate it with some sort of function, typically a line. And so something that would model this data pretty well is a line like this. You know, my line's not that great, but try to make your line straight. This would be a line of best fit because it models what's going on with the data, right? Maybe the points aren't on the data, but the line follows the data's pattern. Okay, that's a line of best fit, or a line that models the data. The line of best fit, there is a mathematical actual line that's the closest that it can be to matching the data, and it's pretty complicated, but we're going to use a calculator to help you get that. I want you to try and sketch what you think just on your screen, what the line of best fit would look like for this one. Would it be like this? Would it be like this? Would it be like this? You know, what would your line of best fit look like? If you drew a line looking like this, that's great. Yeah, that's approximately what's going on with the data. Well, sometimes you have data like this where we saying yesterday had no correlation. It does have a quote-unquote line of best fit. It might look like this, or it might look like this, but the line sometimes isn't that great. And the thing is, there's a calculation for that, and that's called the correlation coefficient. A correlation coefficient tells you how closely the data matches your model, or how well your model matches the data. And what we're going to do to get both of those is you're going to use a calculator. So look at your assignment. You're given a table here of data. These are the meal costs that people had, and then the corresponding tip they gave their waiter or waitress. Right? So someone ordered $6.84 worth of food and left a $1.50 tip. Well, you're going to be putting this data in the calculator and getting a calculator to tell you the line of best fit. So there's a couple options for the calculators. Option one is to pull up that Desmos calculator. There's a link in the module there. And what you're going to do is in here, this table over here, you're going to put your data. And then the X's are going to be your meal costs. And then the Y's over here, those are the tips that people leave. And you're going to put them in there. And if you put them in here, it's going to start plotting the points for you, which is pretty convenient. And it's going to sketch a line. That's the line of best fit. And your job is to write the equation of that line and write down the correlation coefficient. Well, what you have to do to write that is you have to look down here and look at these numbers. It tells you M, it tells you B, and it tells you that Y equals MX plus B, you know, the equation of a line. Well, we're going to take this and turn it into our line of, write it as our line of best fit, which is going to be Y equals, and then M is this number. You're going to get really long decimals pretty much every single time. And so what I want you to do is round it to the second decimal place. So this one, we got 0.135 becomes 0.14 if you round it to the second decimal place, X. All right, Y equals MX, and we add B on there. The B value is here. Again, let's round to the second decimal place, 0.21. Okay, so there you go. There's your line of best fit, and that's going to go here. Y equals 0.14 X plus 0.21. Awesome. And then the other thing you need to get is correlation coefficient, and that's this guy. So R, usually we call it lowercase r, is 0.76. Again, we're rounding to that second decimal place there. So we're going to fill that in, 0.76. And ta-da, you got your correlation coefficient. There's one small thing on correlation coefficient before you do all your problems is don't round to 1.0. Right? If your correlation coefficient is 0.99999. Leave it as 0.99 because a correlation coefficient of 1 means something very special, which we'll talk about in our next lesson. If you don't use the online calculator, you can use a graphing calculator. There's instructions for you. You just pull them up, follow along. You have to change a setting on your calculator real quick, and then you put your data in using your stat menu like we did previously to get mean, median, mode, standard deviation, that stuff. And then you tell the calculator to get your line of best fit. Again, it's going to tell you an A and a B value instead of M and B. It's A and B. Again, you're going to round to the second decimal place. R is your correlation coefficient, not R2. We're not using R2 this year. But yeah, you're going to go ahead and use your calculators to help you get things. And that's going to be our lesson for today. Really just a practice of getting your line of best fit. Either using the online calculator or use your graphing calculator. We want you to be able to get these lines, get the correlation coefficient. And then we'll talk about what correlation coefficient means tomorrow. You'll be doing the next 2 parts of your assignment tomorrow. But yeah, just do the first 2 blanks there. Get line of best fit and correlation coefficient on all of the problems. And we'll see you tomorrow.